Unit 5 Review Geometry. Lesson 1 Area of Composite Shapes, Surface Area, and Volume. Example 1 Area of Composite Shapes. The directions say to find the area of the shape below. So the area that we're going to find, this is our shape. It is a trapezoid. Remember that the solid lines make up our shape. This dotted line is just a reference. We'll use it later. This shape is known as a trapezoid. More specifically, it's an isosceles trapezoid. We know that the two legs, the sides here, they're equal. On a trapezoid, we have one set of parallel sides. So we don't know the area formula of a trapezoid. So what we've learned to do is we've learned to break our shape down into familiar shapes that we do know the area of. So I just set it up so that now we have two triangles and one parallelogram. Let's focus on our parallelogram. The area of a parallelogram is base times height. My area equals the base, in this case, is from the corner of my parallelogram to my right elbow, right? So our base is actually just the 6. With a base of 6, the height is also 6 feet. The area of the parallelogram is 36 feet squared. Let's continue to the triangle. I see that we have two identical triangles. Now we learned that the area of a triangle is base times height all over 2, or 1/2 base times height. The most challenging part of this lesson is trying to determine the base of a triangle. Well, I know that the entire bottom base is 10. The top base of our trapezoid is 6. We need to find these missing dimensions, so the base of this triangle and the base of that identical triangle. So what we can do is we can do 10 minus 6. That will tell us that combine those two bases is equivalent to 4 feet. So if those two bases equal 4 feet, 4 divided by 2, that tells us that the two bases each are 2 feet in length. So area equals the base of 2 feet, the height of 6 feet, all over 2. Area equals 2 times 6, which is 12 feet squared, all over 2. The area of one triangle is 6 feet squared. Remember, we have two triangles. So what we have to do is we can either add another 6 or just multiply it by 2. So the area of two triangles is 12 feet squared. We're not done yet. What we have to do is we have to use the area of the parallelogram and add that to the area of our two triangles. So I know that 36, which is the area of my parallelogram, plus 12, which is the area of my two triangles, equals 48. So the entire area is equal to 48 feet squared.
Example 2 with surface area. Says, what is the surface area of the rectangular prism below? So we can see that rectangular prism, if we take a look at it, it's made up of 6 different surfaces. And the way I look at it is, I'm just going to outline them here. This rectangle that I'm outlining, that's the front. So what we're going to do is we're going to find the area of each surface, all 6 of them. All right, so the area of the front, since it's a rectangle, would simply be base times height. And the base, the length of the base of this rectangle right here, which could be the top or the bottom there, notice that those lines correspond with this one, and that has a length of 10 centimeters. So that'll be the length of the base for for our rectangle. The height, which could be either the left side or the right side here, corresponds with this side that has a height of 5 centimeters. So that will be the height of our rectangle, which means the area of the front surface is 10 times 5, or in other words, 50. That's a bad zero. Let me fix that real quickly here. 50 centimeters squared. And now if the area of the front surface is 50 centimeters squared, then there's also must be a back surface, which we can kind of see way back there, and that must have the same exact area. So I'm just going to label that. The area of the back is also 50 squared centimeters, or centimeters squared. Now we can also see that there's a top to our rectangular prism, and that shape is also a rectangle. So we can find the area of the top, once again, by multiplying the base times the height. And in this case, the length of the base we can see is at 10 centimeters times the height, which would be this side over here or this side over here. And these correspond with this one down here. So that length of the height there is 4 centimeters. So the area of the top surface would be 10 times 4, which is 40 centimeters squared. Which again, if there's a top surface, there must be a bottom surface down here. And that would also have the same area. So we can label the area of the bottom also being 40 centimeters squared. And so what we have left now is on the right hand side over here, we have the right side of the rectangular prism. So I'm going to label that area of the right side. And it's a rectangle, so we can say again, base times height. And those dimensions are very clearly labeled. The base is 4 centimeters times the height, which we can see is 5 centimeters. So the base times the height, 4 times 5, would be 20 centimeters squared, which means the area of the left side over here would have the same area of 20 centimeters squared. So the surface area of that rectangular prism would be the sum of all of the areas of each surface. So we can do this a couple different ways. We could just find the sum of each surface, 50 plus 50, our front and back, plus the top and the bottom, plus the area of the right side and the left side. Which comes out to 220 centimeters squared.
Example number 3 has us working with volume. The problem says the volume of a right rectangular prism is 67 and 2/10 cubic centimeters, and the area of the base is 32 square centimeters. What is the height of the right rectangular prism? Well, first off, we know that volume is everything within a three-dimensional object. We know two different formulas for volume of a right rectangular prism. Volume equals length times width times height, and volume equals capital B times H. Capital B stands for the area of a base times the height. Okay, so when you're reading a problem, you really have to figure out which formula is best to use. And in this case, because we're talking about area of a base, okay, the best formula to use is volume equals area of the base times height. Now let's substitute what we already know. We know that the volume is 67.2 cubic centimeters. So because we know V equals that, let's substitute. 72 and 2/10 equals. Capital B stands for the area of the base. Because we know the area of the base, that's 32, we can go ahead and substitute for that. 32. We do not know the height, so we'll keep that simply h. So in order to find the height, we have to get our variable by itself. We have to isolate the variable. Well, this is a one-step equation. 67.2 equals 32h. I see multiplication in our problem. In order to undo multiplication, we have to divide by 32. In order to keep everything equal, whatever you do to one side, you have to do to the other. So this says 67 and 2/10 divided by 32. 32 goes into 6 0 times. 32 goes into 67 twice. That becomes 64. Subtract to get 3. Bring down the 2. Bring your decimal straight up. 32 goes into 32 one time, and that's an even 32, leaving us with 0 as our leftover. So I know that 67 divided by 32 is 2 1/10. So 2.1 equals, and if you were to look over here, I see a 32 on the top and a 32 down below. They factor out. The only variable that we're left with is our letter h. So h equals 2.1. So the height is 2.1 centimeters.